Hello everyone, welcome to my YouTube channel TechSpot. This is me, Harish Gaupale. So in today's video, we are going to discuss about the module. What exactly the module, what is the purpose of a module in the Verilog, and what is the purpose of module in the System Verilog. As we know that System Verilog is the upgraded version of Verilog. So it may be a different purpose of module inside the System Verilog also, or we can say additional purpose of module inside the System Verilog. Also, we'll discuss how to use EDA, how to use Vivado, and we'll implement one of the circuit in Verilog. Also, we'll verify that circuit by using System Verilog. So let's get start with the understanding of module. What exactly the module is? So basically, a module is a basic building block of any hardware design, and I can say module implements certain functionality such as any hardware circuit such as AND gate or OR gate or half adder, and it defines a block of hardware and can represent anything from simple gate such as AND gate, NOT gate, XOR gate, to a complex system such as FSM, such as Mealy machine, More machine. Okay, so, and module allows you to design hardware hierarchically by defining how different components interact. Okay, and module block should be enclosed within module and in module keywords. So, if we talk about the syntax, so syntax will be module and then module name. So, if you want to implement AND gate, so module name will be AND gate, and then beside that we are having port name. So we know that any type of gate such as AND gate, XOR gate, or NOR gate, we will be having two inputs and one output. So inside the port names, there will be, suppose we are having two inputs, input A and input B. So input A, input B, and output logic C will be there inside the port names. Then signals. So in any module, we can have data signals or control signals. So that can be represented by the signals. And then code blocks will be there. So code blocks will be like any type of procedural blocks such as always at the rate star or always comb. Okay, and then in module. So this is the syntax of module. Okay, now we'll understand what is the use of module in the Verilog, or what is the purpose of module inside the Verilog. So basically in Verilog, module is primarily used to represent any hardware components such as combinational circuit or sequential circuits, and module represents hardware components like logic gates that belongs to combinational circuit, flip flops that belongs to sequential circuits. Okay, and modules allow designers to break down complex systems into smaller usable components. Okay, and you can instantiate a module inside another module, enabling hierarchical system design. For example, if you want to create a 4 is to 1 mux by using 2 is to 1 mux, so you can create a separate module for 2 is to 1 mux, and you can instantiate that inside another module. This is how that is the meaning of instantiate a module. So, for example, half adder circuit, as we know that in half adder, we will be having two inputs such as input A and B, and in output we will be having carry out and sum. So, how we can implement in the Verilog? So, basically, module name half adder, and port names are input we are having A and B, and outputs we are having C out and sum. So in code block, we'll use assign construct, assign sum is equal to A XOR B, and for carry out, we'll use AND gate, and then end module. So this is how we can implement a simple half adder circuit. This is one of the hardware that we can implement inside the Verilog by using module block. Okay. Now we'll understand what is the use of a module inside the System Verilog, or what is the purpose of module in the System Verilog. So basically in System Verilog, the role of module is extended with the additional features to enhance both the design and verification. Okay, like in Verilog, module represents hardware components only, but with additional capabilities such as metadata types like logic and beat. inline port declaration, and more control over behavior using always com. So basically, always com is used for the combinational design. In Verilog, we are having always at the rate or always at the rate star to implement combinational design such as muxes, demuxes, encoder, decoder. In System Verilog, we are having single procedural blocks such as always com only. Similarly, to implement sequential logic, we are having always FF. Okay, so in System Verilog, modules are used not just for the hardware block but also for system level design, where they interact with test bench and verification environment. For example, half adder test bench. So as we saw the design of half adder, there will saw how we can verify that half adder circuit. So for that, you can see syntax module to be half adder is the module name. Then inside that we are having signals such as logic A comma B, logic C out, and some these are our output signals. And this is the instantiation of half adder. Half adder is the module name of half adder design, and this is the instantiation name, instance half adder. And these are the signals. Okay. And then initial, begin, end. In further videos, we'll discuss about initial, begin, and always. Okay. For now, you just understand the this is the syntax and then end module. So this is how we can verify that simple circuit by using this verification by using this test bench. Okay, now we'll understand how to use Vivado. Okay, so here you can see the options, create project, open project, and open example project. So we'll click on this create project. Okay, then click on this next, and then give a project name. So we'll implement here half adder project. So I will give the name half adder, half adder project. Okay, then click on the next. Okay, RTL project, yes, click on the next. Then create file. So inside the create file, by using Verilog, I want to create a half adder. So what I will do, I'll give the file name, that is half adder, half adder, half adder. Then click on this OK, and then next. Okay, next, next, and then finish. Now this will open the terminal. Yeah, it has opened the terminal. Now it will throw one message, whether you want to keep that name as a module name or not. So module name will be half adder. For me it's okay, so I will click on this OK button. Yes. Okay. Now wait. So it has created half adder. We'll click double on this half adder. Okay, and here you can see this is the half adder file. So I will make it better. Okay, now we are having module half adder. Now as we saw as we saw in the video that we have implemented half adder. So in half adder we are having two inputs and two outputs. So we will put input input A comma mm, input input B. By default input A and B are the wire. Then output, we have to mention data type. So output range. About data type, in further videos we'll discuss about all the data types. Output range sum comma output output range C out. Okay, C out. Okay. Now what we'll do, we'll use assign construct because it is continuous procedural block. Assign sum. So it is combinational block. So while implementing combinational circuit, it is recommended to use the blocking assignment only. So we'll use blocking assignment. Assign sum is equal to A XOR B. Okay. Similarly, assign C out is equal to carry out, means to perform carry out what we need and get. So A and B. what it shows? Concurrent assign non-net sum is not permitted. That error gone. So we have assigned sum is equal to A XOR B and assign carry out is equal to A and B. Now we'll click on this open elaborate design. Okay, we'll save this and it will give the half adder circuit which will be having XOR gate and AND gate. Okay, it is processing. You can see this is the schematic of half adder. Now, what we'll do, we'll write test bench to verify this half adder. So we'll go on this source. Here you can see this is the design source, this is simulation source. So in simulation source, we can add TB file. So we'll click on this add source and here add to create simulation source. So we'll click on the next, okay, create file. So by using system Verilog, we'll write the test bench for this half adder and I will give the name TB half adder. Half adder. Okay, now click on this OK and then finish. Now it will throw me message whether you want module name as a TB half adder or not. So I will click on the OK. Yes. Now we'll write a test bench for to verify this half adder. Okay. So if we click on this sim1, so TB half adder. So inside that, yeah, click on this TB half adder. Yeah, now make it big. So TB half adder. Now inside this, hmm, will give signal like as we know we are in half adder we are having two input. So we'll give logic A comma B. Okay, then logic C out comma sum semicolon. Now we'll instantiate half adder. So what I will do, I'll copy this, Control C, paste here, Control half adder, instantiation half adder A double D. Then what we'll do dot half a of here a comma. This is how we have to instantiate all the signals. So b of b dot b is the half adder circuits signal and inside that bracket a and b, these are the these signals a and b. Similarly with dot sum of this sum comma dot C out of uh, C out. Okay, here semicolon will be there. Now we'll write initial begin and then end. Inside that we'll give the value of a and b. A is equal to 1 comma b is equal to 0. After mm, after 10 nanosecond delay, a is equal to 0 comma b is equal to 1. Okay, after 10 nanosecond delay, a is equal to 1, a is equal to 1 comma b is equal to 1. Okay. Now we'll click on this run simulation. So in the run simulation, it will run the behavioral simulation and it will give the waveform. In waveform, we can see the results of half adder. And in you can see this is the waveform. So we'll zoom this waveform and we'll see the result. But we'll click on this. Hmm. So here you can see if both inputs are inverted, then sum is high. As per the XOR gate, if both inputs are inverted, then output will be high. and when both inputs are high, then output is low. Okay, so we have verified here half adder. Now we'll understand how to use EDA. So this is the one file, and this is the another file. So here we can put a design file, and here we can put test bench file, and we'll verify. So we already were having a design as well as test bench. So what we'll do copy and paste only. So we'll go here in Vivado. I am having half adder design. So I'll copy this half adder design, Control C, and Chrome. Inside the Chrome I will put here Control V. Now inside this is the test bench file. So in test bench file I'll put TB of half adder. Okay. Here Control V. I will give the name half adder, half adder. Okay. And from tool and simulator I will choose Questa Sim. So Simon's Questa. Okay. Click on this save button. Now I will run this. So it is loading. Okay. If I'll click on this open EP wave after run, and I'll save, and then I'll run, then it will open the waveform. There we'll see the results. Oh, .vct file is not found here. Now you can see here I have given $dump file and $dump wars. Because of these two statement with the waveform was not showing. Now we'll click on this run button, then it will show the waveform. Okay, so wait for a minute, and here you can see the waveform. When both A and B are inverse, then sum is high and carry out is low. Similarly here also both inverse, if both are inverse, sum is high and carry out is low. Okay. Also here below you can see the display half adder, that is all I have given inside the initial begin. Okay, this is how we can use the EDA playground. So in this video, I have explained about the module, the use of module inside the Verilog, the use of module inside the system Verilog, how to use Vivado and how to use EDA. So basically, this video is for beginners only. So if you are watching this video, then please like the video and subscribe the YouTube channel. Thank you so much.